Hello and welcome to the channel. Today I'm going to be building an ExpressLRS 2.4 GHz transmitter module. I've got all the parts here ready to build the module. I'm going to step through the process. I'm not going to show every soldering step, I'm just going to show the key points in the process. So these are components we've got. We've got the PCB itself. So this was ordered from JLC PCB and I bought in a batch of 5 I think I got. It's often cheaper to buy multiples than just a single item. The Gerber files for these are on the ExpressLRS wiki, as well as the bill of materials for all of the items you can see here. We've got an ESP32 development board, we've got an E28 wireless module, 2.4 GHz of course, a 3.3 volt step down power supply. This is a KK254 Molex connector. We have a pin header for the step down 10k ohm resistor, size 0805. I've already 3D printed the JR bay. We have a 2.4 GHz antenna and an RP SMA to IPEX connector. So the first stage is going to be to place the connector onto the board. Okay, so we have the Molex connector connected, just by soldering the 4 pins there. Prior to soldering, you want to trim the legs so that they're flush with the board. Now what to do for the next stage is kind of up to you. You can either solder this on first, or you can solder this on. I'm going to solder on the E28 module first. The reason being, access to the solder pads is going to be a lot easier without these legs in the way, which will come through from the other side. One thing to remember with this particular part, you should be able to see here, there's a resistor just above the IPEX connector there. This is a 0 ohm connector, and currently in its left position it's using the trace antenna here, which you can probably just about see. And what you want to do is move it to the right hand side, so it's bridging the middle and rightmost pads, which we're going to direct towards the connector instead, which is what we want because we're going to be using an external antenna. As it's a 0 ohm resistor, if you lose it, damage it, it's not too big of a deal, because you can just simply bridge the middle and the right pad. Okay, it's not exactly clean, but as you can see I've got a solder bridge from the middle pad to the right hand pad there. It was a bit of a pain, but I got there in the end. And I've tested for continuity between the UFL connector and the solder bridge. Next up is getting this on here. The E28 module has now been soldered to the board itself. Okay, so the next thing is going to be getting the development board on the PCB. So you're going to need to take off the black plastic strip. This will allow it to get close enough to the board. Once you've taken off the strips, you need to put a piece of tape over there just to give a little bit of a gap between development board and the PCB, just to prevent any shorts. And then once it's been soldered through, then you want to tidy it up by snipping down the legs. Okay, so the development board has been soldered onto the PCB. You don't actually have to solder every pin, though it's not difficult, so I just did it anyway. So I'm just going to trim these legs off, and then I'm going to get the resistor soldered here. So the resistor is soldered on, that's the 10k ohm resistor, and legs have been trimmed. Okay, so now it's onto the step down voltage power supply. So the plan is to step down the 5 volt input to the required 3.3 volt. What you need to do here is one of two things. You can either bridge the 3.3 volts and either cut the ADJ trace or remove the potentiometer, or turn the potentiometer all the way clockwise and then bridge both the 5 volt and the 12 volt pads. I don't fancy messing up the potentiometer by trying to remove it, so I'm going to do the latter and turn it all the way clockwise and then bridge the 12 volt and 5 volt pads on the back. This is the method that's detailed in the wiki itself. I've rotated the potentiometer fully clockwise. I've then bridged the 12 volt and 5 volt pads. This should actually give a slightly higher voltage than 3.3 volts. I've also soldered on the pin header. Now I just want to remove the black plastic, put some tape on the back to insulate it, and then solder that to the PCB. Okay, so the regulator has been soldered on, legs have been snipped. So that should be everything together. Now it's going to be a case of flashing the firmware, which I'm going to use the configurator for. So once the flashing's been completed, I'm going to then pop the module itself into the 3D printed mount, connect up the antenna, and check it out. The first thing you're going to want to do is connect the ESP32 development board via a micro USB cable. It should appear in your device manager as a CP210X USB to UART bridge. If you don't have that, or it's an unidentified device, you'll need to download the drivers and install those. I'll pop a link in the description to the drivers you'll need. Once you've connected, load the configurator. Current version that I'm using is 0.4. So you have your different releases. The official releases is probably what you're going to want to use. Currently the most recent one is the 0.13 release candidate 2. There are releases if you have any special requirements or want to try some of the more bleeding edge stuff, but for the purposes of this we're just going to use the most current release. Then you need to select the target. If you've been following along with this video, I've been using the DIY 2.4 transmitter. I'm using an ESP32 development board, and I have the SX1280 E28, and I'm going to be using it via UART. So I'll select this. Then you've got your options. So you can either use a user-defined text file, or again, more likely you're going to want to just use the options here. Because it's 2.4 gigahertz, there's no different regulations between countries as there would be for the 900 megahertz band. So that's just leave as default. Then you have the binding phrase. So this is what you'll use to bind your receiver and transmitter. So make sure it's the same when you flash both receivers and transmitter. This can be anything you like, so just pop something in the box below. Then the other default options are UART inverted. I leave that ticked and it's been working fine for me on a Radiomaster TX16S. Then you have some additional options, some of which you'll probably want to leave as default, and others you may want to change. For the most part, you're probably going to want to leave these top two turned off. No sync on ARM. It details here the purpose of it, but generally, unless you're doing any hardcore racing where every microsecond counts, you're probably just going to want to leave it turned off. The ARM channel is default to aux 1, which is what I'm using, so that's why I've not specified an ARM channel. If you are using anything different, then you will need to tick this box and select that on channel. So this again is a default option, and as it says here, it lowers latency and should be kept enabled. And this is a feature which requires the ExpressLRS fork of OpenTX to work properly, and I believe this will be part of OpenTX 2.4 when it gets released. If you don't want to use 500 Hz, if you're happy enough up to 250 Hz, then you don't need to use this option. And then hybrid switches, the default is it's switched off, but if you're using anything more than 2 position switches, you're going to want to turn this on. I'm using 3 position switches on my Radio Master, so I turned it on. Once you've selected your release, selected your target, selected your options, then you're going to want to build and flash. It will go through the process as you can see here. It may take a couple of minutes. And then all being well, you should get a green success. When you get the success, you can then disconnect the USB cable, and then you can connect the module to your radio. Okay, and here we have the finished product. Not screwed down just yet. Okay, so I've got the Radio Master TX16S. Let's put the module in, check it works. There's a Lua script that you can download and install. And there we go. I hope this video was useful. Thanks very much for watching.